All right, so the binomial, that means there were two options, two occurrences, and it's success failure. And there's a formula that we learned that had combinations tied to it, but you don't need to use the formula if you know how to use your calculator with the binomial PDF. That basically does it for you. So that's the way I'm going to handle it, is the calculator binomial PDF, and remind you how to do that. Got to set it up first though. So here's my pen. Now on the test, you won't be told it's binomial necessarily. So that wouldn't be up there. You'd say, okay. Yeah, and you only have two choices. Is it normal or is it binomial? You don't know about normal yet. Is it normal or binomial? You know, with the word problems. Okay, so here's the wordy thing. Burglar association reports 34% of the burglars. So there's a probability. Interesting. Okay. Get through the front door. Random sample. That sounds like a N, like lowercase n. Random sample. Sample 36 burglaries. And they're looking at the number of them that going through the front door. So going through the front door is success. That's what they're, sounds weird, but like burglaries is, yes, going through the front door or not going through the front door. That's the complement, that's the Q. So the P would be the probability of going through the front door, which is that right there. This is my P. I'll do it as a decimal. And my Q is the complement. It's the leftover of 34%, which would be 66%, or as a decimal, 0.66. I'm reminded about binomial, binom PDF, and you got an N, let's see, P and X. Yeah, that's on a previous page. That's how binomials are set up. The TI-84s, sometimes you don't have that when you, and I'll show you what that looks like. It'll say trials. So this is trials, T-R-I-A-L, trials. And then P will be shown, probability. It'll say P, and then I think it says X. I'll have to take a look. Once you enter it and you hit enter, it'll display this on your screen, and then you hit enter one more time and it gives you a result, which is a they're asking probability. What's the probability? So what I need is an N. N is equal to 36, and then each problem has its own X. So when I look at A, X exactly, X equals 2. So when I ask for the probability, you go capital P, capital P, X equals 2, exactly 2. You're going to go then binom PDF, and then N is 36, little p is 34%, and X is 2. So what they're saying is if you took any random sample of 36 and you drew 2, no, I'm saying that wrong. If you took any random of 36 and it turns out that exactly 2 were through the front door and the other 34 went through some other location, not through the front door. Exactly 2. And historically, they're saying 34% of the time they're going through the front door. So if you go and say, gosh, 34% of the 36 is about 9 of them, 8 of them, not 2. So I would think That's not likely. Just exactly 2 is low probability, low to me. Because the likely number, remember the word likely? What's likely? Likely. With the distribution, probability distribution, it was the highest probability, but we don't have that. So we have to go with that's likely. And if I took 34% of 36, 34%, 0.34 times 36, 12. I should sort of expect 12. I should expect 12 because historically it says it's about 34%. Do 2, that's highly unlikely. So my probability should be low. Let's take a look and see what happens. You're going to go binomial PDF, so squiggle, squiggle. So we find that by going in the calculator under distribution right here. If you were absent 2 days ago, you would have heard this through my recorded lecture, and also seen that it's all listed in your packet as well as your textbook. So what I'm doing is shouldn't be foreign. It's right here. I even highlighted it. So second distribution. Second, you just have to know on the calculator, but in my video I would have done the same thing. There's the distribution, it's blue. So you go second bars, and then you're scrolling through. Today we're going to do normal, but we're going to scroll through until we get to binom. Okay, now you have 2 choices. Never ever do CDF. If you go to a tutor and they've taken a class, a stat class, and they took a different instructor, they may know about CDF. They may have been taught and they know how to work it. I don't do it because it's many of my students get confused on how that works, even with me telling them. So I choose not to confuse you. I choose to do it this way, which is a little longer, but that's not that confusing. This one, you can get it wrong easily if you don't know what you're doing. So if the tutor says, oh, what's Clark doing? I'll show you a faster way. Don't go there. I'm suggesting don't go there. Just tell the tutor, you know, I need you to go through it Jeff's way. Only because he says, I don't want to be confused. That's all. And then if they say, well, I don't know how to do it Jeff's way, then you say, well, I need to find somebody else. Sorry. Thanks for trying. So if you know how to do it because you had a previous class, well, then as long as you get the same answer, you're good. And here's how I'm going to get the answer. Binomial PDF is always for exact. CDF stands for cumulative, C for cumulative, distribution frequency, cumulative. So when you've got more than 1, see here I just got 1. More than 1 would be like this. See that? At least. That's more than 1. This is where you could use the cumulative, but I'm not going to do that. So I'm going to do PDF on all of these, including this, and this is the one that takes a little bit more time. Exactly 2. So I'm going to do PDF, hit enter. Oh, there's the trials. So N is 36. Okay, then 0.34. Looks like I did that from the previous class. And hit paste. And then hit enter. And you get this, which, okay, I believe we've seen this E thing before. And if we haven't, or if it's been a while, you've forgotten, scientific notation in algebra. So scientific notation means take the decimal. This is like times 10 to the negative 5th, times 10, base 10. Take the decimal and go that direction, which is negative, 5 places. So whatever the power is, go that direction. That means you're going to take what it was is 5.33, let's say, and then instead of E, I'll put times 10 to the negative 5th. That's the same squiggle squiggle as take the decimal here and move it over 1, 2, 3, 4, 5. Put a decimal right there. Fill the hoops with the zeros. So squiggle, squiggle. Okay, so it's the same as 0.0000533. Now, I believe I said this last time, so I'm going to say it again. Probabilities get 4 decimal places typically for us in the author. Everything, if it's not probability, everything else usually gets 2. So 4 for this is a probability right here. So for 1, 2, 3, 4, you look next door to the next one. That's a 5 or bigger. You make that 0 into a 1. Pretty close to 0, but it's 0, 0, 0, 1. That's the best answer for A. And on the multiple choice version, you pick the best answer. You pick the best answer, basically, the one that's closest to this. Letter B. Okay, probability that no entries. Okay, no entries means that you have 0 entries through the front door. No entry, 0. So this is X is equal to 0. Probability that X equals 0 equals binom PDF. Well, for the same reason, the likely number up here, the likely 34% of 36 is around 12. Highly unlikely that it's going to be 0, exactly 0. So the probability should even be lower than that, to me. So we'll see what happens. So equals or squiggle. Instead of a 2, it's a 0. Oh, okay, -7. So further over. So I've got 3 point, let's say 2 times 10 to the -7th. Squiggle, squiggle. 3.2. 1, 2, 3, 4, 5, 6, 7. Bunch of zeros. Squiggle, squiggle. Or close to 0. Okay, the letter C.
Jeff, I have a question.
Yes, go ahead.
On the input in the calculator, I am getting to where it says trials NP and X value. I am assuming, but I could be incorrect, that trials is like for B, trials is 36, P is 0.34, value, X value is 0. And then when I hit enter, I get flashing on the word paste. Yeah. What am I doing wrong?
Flashing.
Did I hit enter again?
Yes, you hit enter again. So
Okay.
Hit paste and then hit one more time. Flash, 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 hit enter one more time. So 2 enters.
Yeah. And then I get the binomial PDF 36.34, comma
Flashing.
0.
Flashing.
And then hit enter again.
Yes.
Okay. Now I'm caught up. I looked away for a second and you lost me.
Yep. Yep. Letter C. Okay, you got the keyword at least. I'm hoping that you're getting better at these words because they're going to come a lot from now on. A lot of these phrases are coming through. You need to be familiar with it because it'll be helpful to come up with the correct answer. I've given you most of the phrases. Where's that least? That least is in there somewhere. Oh, no. Oh, there it is. I already circled it. At least for the other class. Okay, at least has got an equal sign to it. Greater than equal to. So what you do is you go probability that the number of burglaries through the front door is at least, let's see, 34 equals. So now you got more than one. So you've got 3 scenarios in this case. They go through the front, 34 go through the front door out of the 36, or 35, or all of them. Okay, now all of them means you have a random sample of 36 and they all happen to be through the front door. They all happen to be through the front door. Now that's very unusual again, because historically it should only be about 12. But we do it 3 times. So you go px equals 34 plus px equals 35. Keep going until you reach 36 in this case. And then you do binomial PDF on that one, plus binomial PDF on that one, and then add them together. So you're going to piece them together, where the binomial CDF, if we knew how to do it correctly, would do it in just 1 step. 3 steps is not difficult. I mean, it's not that challenging. It's here. I'll do the first one here. I'll just do it right in my calculator. Second distribution again. We look for it. There it is. Oops. Okay, I'm going down here. Okay, 34. Hit the paste and hit enter one more time. And gosh, that's basically 0. I mean, if -7 power is get me to 0, -14 is definitely 0. So I've got about 0 plus, let's see, 35. Even worse, even more 0, even closer. And I bet you this one here is also close to 0. So around 0. Okay. So the mean, you know how to find the mean. Well, in 6.1, I taught you how to use the formula to find the mean of a probability distribution. It's the same as expected value. This one here is a binomial. And when you look at the n times p, I did that for you in the previous problem. Our n was 36 and our p was 34%. And I got about 12. So what's likely, or what's my expected value, or what's the average, should be about 12 point something, not exactly 34. It should be closer to 12. So if I did the same thing with, what's the probability I'll get exactly 12? That should be a higher probability. Should be. Right here, English language, almost 38%, 37.8% they found historically. Letters in a randomly selected chosen text are vowels, A, E, I, O, U. A, E, I, O, U. Okay, those are those vowels, the vowels that they're talking about. If we chose 20 letters at random, the likely number of vowels would be 37.8% of the 20. So mu is equal to 37.8% of the 20. Squiggle, squiggle. And if I go like this, decimal is 0.378 times, not divide, come on, Jeff, times 20. That was weird. Try that again. 37.8. Oh my gosh, come on. 0.378 times 20. All right, almost 8. Around squiggle, squiggle, about 8. About 7.56. Okay, let's just round it because I'm going to count. I'm going to do an example. I'll open up your textbook. I'll randomly open up a page in the textbook like this. Okay. And I'm randomly going to stick my finger right there. I'll start with the word distribution and count letters this way. I'll start with the word distribution and count 20 letters. And then I'll see how many are vowels. And then we'll see how close we are to the, what was it, 8? So 20 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so the 3 words distribution of sample, that's 20. How many letters? 1, 2, vowels, 3, 4, 5, 6, 7, 8. Crazy, huh? You saw what I did. I just went like this. I went like this. Oh, right there. I'm going to put, oh, like look, right there. Start with the word number. Right there. Number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Stop at the E. Stop at the E. So that means right here to stop at the E. And now I'm going to count. I'm going to count letters that are vowels. 1, 2, 3, 4, 5, 6, 7, 8. Hey, look at that. About 8. Convinced.
And this is a type of categorical value?
No. I understand what you're saying because you're looking at words. It has nothing to do with categorical versus quantitative. I'm just, yeah, it doesn't have any, and I understand what you're trying to kind of put it together. Those are categorical words are categorical, but yeah, we're not even worried about that. So
Okay, thank you.
I didn't do a very good job at explaining why, but let's put it this way. For 6.2 and 6. Well, and the rest of it, which is normal for the distributions, they all have to be quantitative, not categorical, all quantitative. And you'll see the examples, quantitative, numerical in nature.
Okie dokie, thank you.
Oh, and the standard deviation is, again, just a number. Who cares? Just plug it. You would put in the n is 36. That's going to be 34%. That's 36%. And then take the square root. It's a number. Has nothing to do with anything for us right now. So it's plugging it into the formula and just getting a number. And since standard deviation is not a probability, you would say round to 2 decimal. Round to 2 decimals is pretty typical for our author. Okay, well, I think I said we only have one section today. That's new. and we get the introduction to what's called normal. And that's where we get the bell-shaped curve. So here's where it's continuous, where binomial is discrete. Normal is continuous, binomial is discrete. Oh, even here. What the heck is a Poisson? Okay, that's a different distribution. I'm not teaching you. What is a geometric? Well, that's a different distribution, and I'm not teaching you that. But there are other distributions. Maybe a, well, some instructors here at SRJC will go through these two. I don't have time. I go straight almost to the normal. That's the one that's used, for us anyway, the most. But do you see the CDF and the PDF? They all have a CDF and a PDF. Okay, anytime you see a CDF like this one, continuous. You can think C is continuous. PDFs, discrete. Continuous, discrete. Continuous, discrete. That's why I want this one to be discrete. I just want that to be discrete. Okay, going up here to the normal. Normal, where are you? Normal. Okay, normal. We want CDF because it's continuous. Just think of it that way. CDF, continuous. I don't want PDF. Don't want that. So normal, I'll always use CDF. Binomial, for me, Jeff, I'll always do PDF, binomial. All right, so it's continuous. And reminder, oops, you don't see that. Reminder, if it's continuous, height, weight, time, temperature, we've talked about those examples back in chapter 2, or chapter 1 actually, and then GPA. Bell-shaped curve is what we're going to call is a continuous histogram, looks symmetric. And for us, perfectly symmetric is normal, perfectly. This one's not perfect, it's close. So it's around symmetric, I would say, versus, remember it's left skewed and right skewed. That's the other choices we have. Oh, much more symmetric. Matter of fact, if I just looked at that, looks like all the bars right here in the middle, which is the mean, median, mode. Remember that? Mean, median, and the mode right there in the middle. It looks like a mirror image to the right as it is to the left. And of course, it has this feel of a bell-shaped curve. For histograms, you guys were taught by me that, well, the author, typically when you build a histogram, 5 to 20 rectangles. I think there's might be more than 20 here, but that's okay. That's not typical. This is skewed, right tail skewed. That's not normal. Not normal. It's skewed. This is the normal one.
That right skewing would also be considered positive, correct?
Sure. I think our book doesn't use the word positive, negative. It
Okay.
uses right or left, or right-tailed and left-tailed. Not normal. For a given continuum, we're not interested in whether it looks like at a particular value, just whether it's greater than, less than, or in between. So you're not looking at it exact, you know, like the binomial. What's the probability that it exactly 2 burglaries through the front door? Exactly. We're not looking at that. We're looking at what's the probability that between 3 and 32 burglaries, so there's a range right there. And that would be more continuous. But binomial in general is discrete. Okay, so let's see. Yeah, I said here. It turns out, this is weird for some of you. I don't have, probably today it's not going to be clear even after today. What are you talking about? The probability is always equal to 0 at a, like P of X equals, I'll just use the number 32, is going to be 0. Every value exactly at those numbers would be 0. Sounds really weird. Now, here's an illustration I came up with. Okay, we go and get a soda, and 12 ounces is a typical can of soda or a bottle of soda, or water or whatever, liquid that you're going to drink. It says 12 ounces. You ever wondered if you're getting cheated or gypped? You know, there's a little extra at the top. If it's a clear bottle, you can see they didn't fill it all the way to the top. Or can, when you open it up, it looks like there's a little area right below the lip, you know, the opening, that it's not right up to the top. Now, I'm supposed to be paying for 12 ounces. I'm wondering if Pepsi is cheating me, or maybe the can is bigger than 12 ounces. That's a possibility. I'm getting liquid ounces, not the size of the can. So what you could do is, if you had a measuring device, a very precise of measuring liquid, you could take your can of soda and tip it upside down, pour it all out, and then take a spatula, get all the liquid out, and measure it. Excuse me one second. You think you get exactly 12 ounces on that can of soda? Do you think you get exactly, precisely 12 ounces? Oh, I see Agnelli drinking a soda. Are you going to get 12 ounces out of that? So it looks like with a 12-ounce can that you just drank. Does it say 12 ounces?
It's 15.5 ounces.
How much?
15.5.
Oh, it's a bigger can.
Yeah.
Do you think you're going to get 15.5 exact ounces? You ever thought about measuring that? And so the probability, the likelihood of getting exactly 12 ounces, it's probably not very big, because, gosh, what do? They have machines that fill up each can. Maybe there's a little dribble that missed, or a little dribble extra that got there before they put the lid on. That's why the probability is 0 that you'll get it exactly, because it's highly unlikely. What's the probability that you're going to get ounces, let's say, for Agnelli's, between 15.4 and 15.6 ounces? If it says 15.5, well, it's probably pretty likely. It might be about 99% chance that I'll get something in there, probably. That's why we're going to look at a range. A range. Could it be that? Could be 12-ounce can. It could be. Could even be that. Real close. So what we're going to do is, under the curve, you know, the bell-shaped curve, the area under a curve. Now, you guys know how to find areas of rectangles. You should, because you guys are former algebra students. A rectangle's area is length times width. Now a curve is, gosh, you'd have to use calculus to find the exact area under the curve. And you aren't calculus students. So we assume that the area under the curve is 100%. That basically we're looking, it's probability. Area under the curve is called probability. Okay, there's a curve. What's this? Well, think of that as like the x-axis right there. Jeff, why didn't you pinch it over there? Well, you just don't. You know, why don't you just go like this? And goes like this. Not good. I'll say not good. Because if this is ounces, you know, this is ounces of soda, is it possible? Well, let's say the can truly is 15.5. I mean, holds that. Is it possible that you get something beyond 15.5? Well, not highly likely. What about possible going the opposite? Could they screw it up and the machine screw it up and get, you open it up, says, whoa, I got a weird can. I got half. There's a lot of empty space. So it's possible, highly unlikely. Remember everything out to the left-hand side of 3 standard deviations and to the right? Remember the z-scores? I'm reminding you, if it's beyond 3 standard deviations, remember here comes the standard deviations, they're called outliers. So we're coming back to the phrase of outliers now. And z-scores, that's what we're going to be looking at, is z-scores eventually. So it never touches. So it goes on forever. It goes on forever. And the area that's under here, I'll do it in red. The area is called probability, area, all of it, forever is 100%. Forever, 100%. What you're going to look at is a portion of 100% because it's highly unlikely you'll have an answer of 100%. It's 100%. It can be close, but it won't. Let's say you have this amount. That's less than 100%. It actually looks like it's less than 50%. Remember half of it? That's like half of it right there. You know, it looks like less than 50%. So now I've got it down below 50% just by observation. You're going to find out how to find it more precisely. Reminder. Here's a reminder for you. Back in chapter 3. Oh, here it is right here. We talked about between 1 standard deviation, in between, about 68%, that's a probability, of the data is between the first standard deviation on the left and the one on the right. Yeah, and there are pictures for you in the textbook. I don't think I have them in here. Pictures for you in the textbook. Oh, here's some more. 68% of the students that took the SAT scored between 400 and 600. And then there was like the 95% would be the next 2 markers and 99.7%. We're coming back to that. Coming back to it. Okay, the behavior of our natural world can be described as usually as normal, bell-shaped curve. So the amount of rainfall, you know, these are just some thoughts and examples. Heights and emotional intelligence scores of college students, errors in manufacturing machine bolts, so on. Now, parameters, right here, the word parameters goes with population symbols. Here's 2 symbols, parameter. Another one is sigma squared. Parameters and population symbols, they go together. The word statistic goes with sample symbols, statistic, lowercase statistic. So, and you'll see that in your textbook too. Normal curve is symmetric. You get mirror images like I did right there with the picture. Jeff, this image looks like they touch. If you had a magnifying glass or a microscope and got it down there, you'd say, oh, I see it. They don't touch. They get really, 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 really close, but they never touch. So try to make your pictures in such a way they don't, like for group quiz or your homework, try to make it so that they don't touch like that. That's pretty good. Don't make it look like that. Make it look closer to that. Okay, what about the bump, Jeff? That's pretty flat, so you can make it higher. There is a difference in why you would make this higher than that one, kind of a lower. There is a difference. I'm not talking about it today though, but so I don't care about your bell on what the height is. I don't care about that. Just make sure you don't touch the ends for me. Oh, and then eventually you're gonna, like draw something right down the middle, and eventually you go 1, 2, 3 tick marks, 1, 2, 3 tick marks. So eventually that's what you're gonna do for all of your pictures that you would submit to me, or interpret the picture that I give you on the multiple choice test. Can you interpret the pictures? So that'll be 3 markers to the left, to the right of the center, and 3 markers to the left. Jeff, what about here? It looks like there's 4 markers. Well, okay, that's a 0 down here. If you can't see that, hard to, but that's 0. That's a 1, that's a 2, and that's a 3. I don't need to do 4 because anything beyond 3 is outlier. The probability is virtually nothing, 0. And over here, that's a -1, -2, -3, and so on. Characteristics of the bell-shaped curve. I've listed 7 of them. Those are the pretty typical, the main 7. There is only one mode, and it's found right at the peak. Remember, the mode is the highest. It's the most frequently occurring. It's the middle as well. It's the median and the mean. Continuous area, blah, blah, blah. Okay. So when I look at this example that's right here, most of these problems are not asking you to go out and gather data. Most of these problems, they've done the work for you, and they're giving you results. Your job is to draw the picture and put the markers down and do some shading. I'll do that today for you. And I'm going to label markers down here with the raw data. I'll do that for you too. And then come up with the answer, what the probability is. And we can pretty much do it without a calculator today, because we're going to use a picture. This picture over here, found in your textbook too, but this picture, most of the problems, if not all of them, are set up so that your numbers that you're looking at are right at the markers, right at the hash mark. So you could just use the percentages as you see. On Monday, they won't be right at the markers. They'll be somewhere in between, and you'll see those on Monday. So if I were to do this one, which I'm going to guess right now, and you want to put right there in the middle. Now, if you want to put a line, that's fine, or you don't have to. What you're going to put in here is mu. So a survey found that people keep their TV sets on an average of 4.8 years. In sigma's 0.9. So what do? I don't know. Somebody's standing at Costco. You go into Costco, first thing you see up there is usually the big screen TVs. Catches a lot of people's attention. And I see a lot of people putting it on the cart, 60, 70-inch TVs now. So people are buying still a lot of electronics. So let's say you're there, and your job as a student of SRJC is just to ask them, hello, sir, would you mind? Okay, what are you doing? You're doing systematic. or convenience. Let's call it convenience because they're the ones that are just standing there next to you. Hello, sir. Hello, ma'am. See, it looks like you're going to buy a TV and make a purchase. Can I ask you a question? Simple, just a simple question. How many years have you owned your TV that you're replacing? Because, you know, let's say, oh, maybe you have two questions. Are you replacing a TV or not? If they aren't, then it's brand new. If they are, you say, well, how old's your TV? The old one. And you're gathering data. And so let's say someone says, well, I've had my TV for a year. I just want the new, better stuff. Oh, okay. So you put down 1 year. You go to the next person. Hello, ma'am. How long? I've had mine for 20 years. That old black and white ones worked, and it finally gave up. So finally buying my first big screen smart TV. Oh, and you put down 20. Anyway, you maybe collect 100 people's responses. And this, you found out that when you add up all the years and divide by 100, you got 4.8. So that's your mu. Or that's, in a way, you might say, that's not mu, because this is weird. It sounds like, hey, you asked everybody in the world, because that's a population. That's weird. Later on, we will look at something more real, which would be little s instead of sigma, and x bar instead of mu. Today, we're just kind of setting this thing up as follow the bouncing ball. Don't ask questions. Mu, this is 4.8. How many tick marks, Jeff? Remember, we decided 3. 3 to the right, 3 to the left. Oh, yeah, that's right. Kind of space them out evenly there. Okay, how do I find that marker? You guys just need to be reminded, but we've done this about 2 weeks ago. You were tested on it. You find what the standard deviation is, which is the distance right here. Same distance here. That's called standard deviation. That's how far this next marker changes or deviates from, in this case, the mean. And you add it, going to the right, you add it to 4.8. And they telling you right here, there it is. How'd they get that, Jeff? They used their calculator. They put all the raw data in and used the calculator and got a number and rounded it to the 10th place instead of the 100th place. That's all. So 4.8, and this is 4.8, and then you add 0.9, so you get 5.7 for that next marker. And so all you do, going to the right, is take 5.7 in this case and add another 0.9. And add another 0.9. And over here, you're subtracting 0.9. So 4.8, subtract 0.9. Okay, now, if you went back the next day and you're going to say, I'm going to use this information and I'm going to survey another 100 people at a different Costco. Let's say you're going to the Rohnert Park one this time at a different time of day. The probability, the likelihood of someone saying they owned it more than 7.5 years is basically 0. It's an outlier. It's hardly anything. And someone saying they've owned their TV set less than 2.1 years, it's about 0. Someone who says they own their TV set between 3.9 and 4.8 years, that probability right here would be about 68%. Why do I say 68%? Well, it's in between here. It's about 68.2%. Oh, well, what's the one we want? Less than 4.8 years. Oh, well, then you go like this. 4.8 years, less than. Okay, Jeff. The less than does not include the equal sign. So how about this? You guys remember doing, oh yeah, you just forgot. So I'm reminding you. Remember when you did linear inequalities where you did graphing and shading? Graphing lines and shading? You had to have. And when we did the shading, you decided to do a solid line or a dotted line. You do dotted when there's no equal sign. So less than, right here, less than, it looks like that symbol. So why not just do dotted? And then less than shade, 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 shade. So then what you say is what's the probability that X equals owns TV in years. So somebody owns their TV less than 4.8 years. Squiggle, squiggle. Well, it's 50% based on the results that we had from someone giving it to us. It's about 50% because it's half of the curve. So if I'm not mistaken, 6.1 is going to be really nice that they're going to give you numbers that are on these lines, and all you're going to do is say, okay, add up these percentages as you go, somehow. All right, let's try this one. So same problem. This is 4.8, 1, 2, 3, 1, 2, 3. Sigma is still 0.9. Okay, less than 39. Oh, okay, so you go PX less than 3.9 years. So let's see. Well, that's less than 50%. So remember, this is maybe your center line right there. So if I look directly above, that center line is about 34.1%. This region right here, just this amount right there, is about 13.6% in between these two markers. Between these two markers, it's about 2.15%, and there's a little bit left over. So maybe the red can be found out knowing that this is 34.1%. How about the red? Red probability would be 50% subtract 34.1%. That amount is 50%, half of it, subtract the amount that I don't want, and that will be squiggle, squiggle, what I do want in red. (15.9%). So this is about 15.9%. The likelihood that someone comes in and says, well, I own my TV less than 30.9 years, there's a 16% chance that's going to happen. Or if you do it, if you survey 100 people, because percent's out of 100, you survey 100 people, you should get 16 of them saying out of the 100, 16 out of 100, 16%, saying that they own their TV less than 3.9 years, around, pretty close. Oh, same problems, just a little different where we do the shading. Okay, more than. Well, you got to determine if it's got an equal sign or not. And you look at the back of your packet to convince yourselves that more than does not include the equal sign. And then 6.6 years. Okay, so here's your center line. More than's got no equal, so it's going to be dotted again. So that's the shaded region I want. Again, same thing, 50%. Take away what you don't want is what you're left with. So 50% take away. Now, how much we have to take away are really two regions. Remember this, two region? That's about 34.1%. Where do you get that, Jeff? Oh, over here. It's about 34.1%. and 13.6%. So these two regions have to be combined. This is about 34.1. This is 13.6, I think. And so you've got 34.1% and 13.6%. And using my calculator gives me the leftover. So 50 subtract 34.1 and subtract 13.6, 34.1. Uh, 2.3. So squiggle, squiggle, about 2.3%. Or squiggle, squiggle, 0.0, let's see, 1, 2, 0.023.
Did you add it or subtract it, Jeff, inside the percentages?
In here? In here?
Yeah, in the calculator, I think I saw a subtraction in yours. I could be mistaken.
Well, in algebra, remember I distribute.
Got
You
you.
can add these up together and then subtract that total from 50. So what I did is I subtracted both of them from 50.
Cool. Thank you.
Yep. Okay, this one here, you go here, this is 4.8. 1, 2, 3, 1, 2, 3. Okay, so maybe this is a center line again. Okay, between. So probability that X is between. Okay, so 3.9 is smaller than 6.6 years. Now, between is a little peculiar if you just use the word between. I think your author says between and inclusive. That means you're including those numbers. So otherwise, in between could be a little ambiguous. It won't make a difference in your answer. I'll just tell you that right now. So if you chose to make it equal, great. If you chose not to, it won't make a difference. However, on the group quiz and on the homework, if I find it, but on the group quiz in particular, if you don't include, or if you put an equal sign on this one, you're wrong. and I would take off some points because you're not getting the right symbol from the right phrase. So on the group quiz, I'm going to be very picky and take points off. Even though the answer won't change, it's about understanding the language. On the exam, you're just picking the best answer. That's all you do. Pick the right answer. Hopefully you do, and then everything's good.
So wait, which would be the right answer? You said it's not the P parentheses X is greater than X.
Or this is okay. This, because it's the word between, it is ambiguous. Between, do you exclude the endpoints or do you include the endpoints? I don't know. What do you want me to do, Jeff? Well, I want you to include them. Well, then why don't you say that? Okay, sometimes books don't say that. And I'm going to show you what ours does. I think they use the word inclusive. And if they use the word inclusive, this is inclusive. That would be the equal signs. But I'm okay with this because I won't be picky on the between. I guess that's the thing. I will not be picky. I won't take points off whether or not you put equal or not. And in your textbook, what's the probability that blah, blah, blah between 3 and 4 seconds? I don't care if you use less than or equal to or less than. I don't care because it doesn't say, this one doesn't say inclusive. I mean, if it did, then you'd have to put an equal sign. Same thing here. I'm looking for something else. Let's see. Oh, down here at the bottom, there's another one. He just uses between. It will make a difference in your answer.
So just to clarify, inclusive means equals.
Correct.
Perfect.
But that's very definitive. Yes. If they throw in the word inclusive, oh yeah, then the symbol that I'm going to be picky about would be the equal because it says inclusive. But if it doesn't say anything, then you get to use either one of these. Okay, so I'm going to go over here. 3.9 is, since I'm going to use this one. So that means I do a solid line here. And 6.6 would be solid line right here. And so you're going to have this amount and all of this amount. And how to find that is you take regions and add the probabilities together. Now remember this amount on the left-hand side is 34.1%. That amount where my finger is 34.1%. And that one is 13.6. So I'll write that in there for you. This amount is 34.1%. This is 34.1%. And this is 13.6%. So you add them all together and it gives you the result that we need. as a decimal, or 81.8%. I got more than I thought. Okay. Give me a second here. Okay. All right, the next one is z-scores. So from previous sections, z-scores just takes raw data and turns it into numbers that range usually between -3 and 3. Z-scores take X as a raw data and you subtract the average. So you have to know something about the average and the standard deviation. It takes a raw data score and turns it into a number, they call them z-scores, that range from 0, down here you'll see it, and 1, and 2, and 3, -1. You don't need to go to 4. And we will not do tables in this course. We will not do tables, but there are tables in your textbook. We're just going to use the calculator. So not by 2 methods, only by 1. And it's not hard. So you'll see it. Using the calculator, it's not hard. Just like binomial PDF, once you do it a few times, it's not hard. Okay, so these will have z-scores. So your picture will always look the same in this case. Zeros, -3 to 3. And this is your calculator keystrokes. Just a reminder. Page 332 is another place to find your instructions. At the end of each section, there's calculator instructions. At the back of our packet, there's 3 or 4 pages that has very detailed calculator instructions. YouTube videos, if you want to say, oh, how do I do my 83 calculator with normal? That's called normal. So I'm highlighting that. See, notice it's normal CDF. That's what we're going to do. Smaller, larger, I have to explain what that is in a second. The mean is, you're always going to be given the mean. By the way, if it's a z-score, it's going to be 0 every single time. The mean for a z-score will always be 0. Standard deviation will always be a 1. See that right there? So for today, it looks like that's will always be true. Okay, what do I want to do? Okay, go over here. Find the area probability to the right. The right does not include it, to me, of 0.57. So this is what you'll do. Let's see if I can put these numbers in a little more solid. So this is 0, 1, 2, 3, -1, -2, -3. Okay, now I'm going to find this. So if I'm going to do probability, you'll say probability that the z-score is to the right, that's greater than 0.57. So with my blue pen, 0.57 on the number line is about right there. About right there. And then to the right, now, if you used your picture that showed percentages, you can kind of guesstimate about how much. It'll be, like a rough guesstimate. Definitely less than 50%. See the blue shaded regions? Definitely less than 50%. 50% is from the halfway mark to the right. So it's the shaded region is less. So this is what we're going to do. I'm going to go to normal CDF, which is under second distribution again. Second distribution. Oh, and I want normal CDF. So it's the number 2 right there, number 2. Now, smaller is the same thing as lower in the calculator. Smaller is lower, comma. Larger is upper, comma. Mu, comma, sigma. All right, so here, where's the lower? Well, there's the lower. In terms of the shaded region, that's the smaller number that you're going to type in, 0.57. Okay, what about the 0? Okay, 0.57. Upper. Okay, now the upper goes forever, like this, forever. Well, how far is forever, Jeff? Well, like infinity. You're not going to type in infinity, but pick a number large. That's what I'm suggesting. Pick a really large number. Go way beyond 3. Oh, okay. Well, let's see. Way beyond 3. How about 3,000? That works. So 300 would have been okay too, or 3 bazillion. That's such a word or number. Okay, mu is always 0 for these problems. Sigma is always 1. Go down here and hit enter, and then enter one more time. So remember I said this is about less than 50%? Well, I got about 28.43%, or as a decimal, squiggle, squiggle, 0.2843. So tables, this says table. We're never going to do a table. Calculator is always calculator, so you'd say it's about 0.2843. Oh, up here. I didn't do this one, did I? To the left. I think this one says left. Probability that the Z is to the left of 0.57. Okay, that's still right here. Okay, well, more than 50%. Matter of fact, isn't this the complement of that? Isn't that shaded region the complement of that shaded region? The answer is yes, because it makes up a whole. Now, so you could have said, I'll just take this number and subtract it from 1, and that'll give me the answer. That's true. Or you could do a calculator, like I'm doing right here. I could put those numbers in. Again, normal CDF. All right, now, when I look at the picture, how far left am I shading? Negative infinity, or how about negative really big number? I said negative 10,000. So how about negative 10,000? Sure. Okay, how about even bigger? Sure. Sure. As big as you want it. Just make it really ridiculously big. Okay, now, how far am I stopping to the right? Because that's called the upper, is 0.57. So go down here and go 0.57. Always 0, always 1 for sigmas, for standard normals. Okay, these two numbers together, right here, give you 100%. Supposed to, or really, 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 really close. So I'm going to round this to 4 decimals. So squiggle, squiggle, 0.7157. 0.7157.
So that's finding it to the left or to the right?
That's to the left, right here, to the left.
Got you. Okay.
So right here. It's what I typed in right here. Well, actually, I typed in more than 10,000, but negative. But to the left
Right, it goes on and on.
is this way, negatives. And then I stop to the right, or the upper. They call it the upper. So first number is called the lower. Second number is called the upper. I call it the left. That one's called the right on the number line.
So basically, from what it sounds like, it doesn't really matter what the number is as long as it's negative and positive and it's above the what's it called, blue score.
Yeah, big, super big or super small. Uh-huh. Just as
It's
long
got to
as
be
it's
above
not-
3 or negative 3.
Yeah. That's right. That's right. That's
Okay.
exactly. Yep. Okay, here's one that's called between. So then you go over here and say, all right, what's between? Well, let's see, 0.57 still right about there. 2.13. Okay, that's in here somewhere, kind of closer to the 2. Okay, so probability that the Z is in between 0.57 and 2.13. So I'm going to go like this. And then what you can do is you'll do the normal again. Now, what's my lower in this case? Look at the picture. What's the lower?
0.57,
Right. 0.57. And then the upper, Jan?
2.13.
Correct. 2.13. And that stays the same. That stays the same. Mu is right there in the middle. That's 0. Paste, enter. Okay, so not the table. We're doing the calculator. So this would be, if you want to put the answer over here, 0.2678 for rounding. 78. How come 8? Well, there's the 4th decimal places. Look next door. 5 or bigger makes that going to make that an 8. That's your rounding rules. Let's see something else. Yeah, question?
No, sorry, it took me a second to understand. So whenever it says like the probability is in the calculator box, it's that is what you put in there, right?
I'm not following. You have to
Like
rephrase that.
the P parentheses 57% less than Z, which is less than 2.13.
Oh, this right here?
Yeah.
Because it's between. The word between.
But wouldn't
number.
in between be like 57.57 is no, never mind. Never mind. I just answered my own question.
Uh-huh. That helps. Sometimes if you answer your own, that's better than me. Okay, flip the page. I'm not gonna do those. I'm not gonna do that one. I'm not gonna do that one. Okay, I'll do these. These two are kind of funny. These two are really interesting. Okay, so let's see, 4.98. Well, that's way over here. Right, so I'm gonna go like this. There's 5. 4.98 is like right here. So I want to go to the right. Probability that your z-score is to the right, 4.98. Well, then I'm going to go like this, and not much is shaded. What do you think the answer is going to be about before I even do anything? Anybody? What do you think the answer is going to be?
0.
Right. It should be around 0. Should be. Well, let's see how close we are. So I'm going to go normal. Okay, my left is 4.98, or my lower is 4.98, 4.98. And then my upper is infinity, or big, ridiculous, like a lot of zeros there. Big, ridiculous. Enter, 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 enter. Oh yeah, there's that negative exponent thing again. Yeah, that's pretty close to 0. No tables, pretty close to Z. Okay, this one here, kind of unusual. -8's not on the number line. Yeah, okay, well, let's stick it way over here, I guess. How about there, -8? This one's to the right again. Probability that Z is to the right of -8. So then you're going to go over here and to the right. Huh. Well, that's about everything. I think it's going to be very close to 100% or 1. Okay, let's see how close we are. Distribution, normal CDF. Okay, -8 is the left, and the upper or the right is that again. Okay, enter 1. 1. Oh, so close to 1, it's 1. About everything.
Jeff, I have a question.
Uh-huh.
So, for example, where you said that it's equals to 100 or 1, let's say like on a group quiz or on the test, you had an option of 100% or 1. Which one do we click, or would you just have
Okay, on the quiz, your choice. Your quiz, your choice. If it's a decimal, it has to be 4 decimal places. If it's a percent, then I want 2 decimal places, which is equivalent to 4 decimal places for a decimal number or quiz. On the exam, you're just picking the answer. I mean, there's only going to be one right answer, so you pick the right answer, hopefully.
So you would have either 100 or 1, not both.
Exactly. I would not have both. I wouldn't confuse you that way. Yep.
Oh, thank you.
Yep, and the rest of it's just more of the same, which I'm not going to do. Just more of the same. I'm not going to do those.